All right, lesson set 20, problems numbers 30 to 57. Let's have at it. Let's get a good practice session in. Not spend too much time on problems that in earlier lesson sets you've practiced quite a bit. So first question was distance between the point 37 and 710. I wish I hadn't the same number here, but I do. I've got a y value. That's a y value. That's an X value. All right, so from 3 to 7 is 4 units of change, 7 to 10 is 3. There's your classic 3, 4, 5 triangle, so the distance is 5. Again, trying to get that 16, 9, 25 picture in your head. X minus 5, to get minus 4, I need 1. We should be at that stage to get the first two terms. 1 times negative 5 is negative 5. How do I get from negative 5 to 3? I add 8. How do you check your work on a test? The critical number here is 5. The remainder is 8. If I put a 5 in here, I could get an 8 out easily by putting the 8 outside the parentheses. Hopefully you can see a 5 gets us an 8. Over here, a 5 has to get us an 8. So we do 25 minus 20 plus 3, and I can see 8. Moving on. 2 plus 3i gets multiplied by 2 minus 3i, and you should at this point see that 4 and 9 make 13. Go ahead and do it out. You should get 13. I'm multiplying this fraction by 1, so I'm not changing the amount of this fraction. I'm changing the way it looks. 4 times 2 is 8. Minus times a minus is a positive 6i squared. 8 minus 6 is 2. And then I get minus 4i, minus 12i, minus 4, minus 12, minus 16i. Hopefully I thought about that enough not to make a careless mistake. Next problem is a challenge question. Going to take it right off the test. I was trying to get folks to realize that the base of this exponential function has to be positive by definition. So we'll move the log base 2x to the other side. We get 2x cubed. 2x cubed is 8x cubed. And when does that equal x cubed minus 8x squared? When we bring those terms over to the other side, we get 0 and negative 8/7. I cannot have the base 2 times 0. 0 to the x makes no sense. And minus 8/7 times 2 to the x also has many difficulties. Okay, so I will be replacing that with the point of inflection of the cubic. So let's do that one right now. I'm not sure this is the exact one that will be on the test because I already changed it on the answer key and I don't have the answer key with me. So minus b over 3a from previous tests and conversation in class is the point of inflection, the x value. So minus b 12 divided by 6 is 2. So I now know that I could start this 2x minus 2 cubed, x minus 2, and I'm trying to find out what goes with the 2. That goes here. This multiplier is c minus 3ah squared. Doesn't hurt me to put that in your brain. So whatever that multiplier is tells me if I have local maxes or mins, and that's for another day and another discussion. Let's just drop a 2 in. 16, this better be minus 48 without looking because it's a 3-to-1 ratio. Plus 20 minus 5. Okay, so that's minus 32. Plus 20 is minus 12 minus 5, I believe is minus 17. So I believe the answer is 2 comma minus 17 if I'm not too close to the board and making a mistake. All right, we're now doing the cube root. So we're looking for multiples of 3. Well, that's a nice multiple of 3. So I can take x cubed out. That takes care of x to the 9. Y squared, sorry. Can't rename that. Z to the 7th is z to the 6th times z. Well, that's a nice multiple of 3. So I can take z squared out. And I can leave a z in. And then 24, I hope you see, is 8 times 3. And what's the cube root of that? I can take a 2 out. I can leave a 3 in. All right, we talk about more than that in class as we do the problems. Oh, Rene Descartes. I left Rene over there. One of these days I'll remember. Did I remember an eraser? No. Did I remember Rene Descartes? No. Do I remember my name? Probably not. So this is x plus 5. This is a retread. It was on a previous test. And this is just my check to see if you're looking at your test corrections. Exact same question as the last test. Now you might be embarrassed if you get it wrong, and you should be. Excuse me, I feel like a grumpy old grandpa. All right, so x plus 8, x plus 5. So we can see that becomes 1 over x plus 8. Divided by means multiplying by the reciprocal, x minus 9 over 4x. So I'm multiplying that by x plus 9 over 4x. Not a whole lot of cancellation here. So my final answer, x plus 9 over, I suppose we can multiply it out, 4x squared plus 32x. I don't know if I multiplied it out on the answer key or not, because I don't remember doing it. Lots of things I don't remember. All right, so shortcuts to this problem galore. I don't want to take any. I want to look at it graphically first. That's a graph. X-axis. 3 gets me 0, and then I have a function that is increasing slowly. X minus 3. Well, the y-axis is over, oops, I put it on the wrong side. The y-axis is over here. And if I put a 0, -3, and I know I'm going up at 1 to 1, wow, it's hard to tell how many points of intersection without doing a little more work. I mean, I can see what it's going to do, but let's not in this case, because the problems get considerably harder as we go along. So you're going to square this side, you're going to square that side, and I want to make sure people get plenty of practice squaring that in the mind's eye. All right, I do not want to see x squared minus 9 for that squared. That's a real problem. So is erasing. All right, so we set to 0, we get x squared minus 7x, add 3. I believe we get 12. Did I do this right? Yep. Add 3 gets 12. And I can see that x minus 3 and x minus 4 gets the job done. So yes, this did intersect there, and it did intersect there. And I hope you can kind of see we're heading in that trajectory. So your answers are 3 and 4. Let's check them. 3 minus 3 squared is 0. 3 minus 3 is 0. That's true. 4 minus 3 is 1. 4 minus 3 is 1. That's true. They both work. All right, next problem. If you keep doing the next problem, I hope you don't have to do the problem. Imagine that. Here's a problem you don't have to do. You can just write the answer. X squared plus 4x plus 29 equals 0. All right, let's find out why you can do that. Well, minus 2 is going to become positive 2 on the other side. There's a sign change. You're going to end up squaring that. There's x squared plus 4x plus 4. X squared plus 4x. 5i on the other side, plus minus 5i. And when you square that, you're going to get 25i squared, which is negative 25. And negative 25 plus 4 is 29. Sign of A, right triangle, 49 minus 9 is 40. That's the square area. So what is that length? Square root of 40. And the sine function is opposite the angle divided by hypotenuse. Move on. I think we can see this one as it's written. So I'll start with y equals 2. This is an exponential function. How do you get from 2 to 10? You add 8. Okay, we did that. I can see 2 and 10. How do you get from 2 to 31? Well, I can tell you one thing. You don't add 8. I think 2 to 31 is 29. A little more than quadrupling. I want to show 1800. Make it a 0. Anything with 0 is 1. 8 plus 2 gets me 10. 2022. When I put that in, I change by 222 years. 222. That was well written, Jim. 222 years brings me up to 2022. And that brings this number to 1. 8's cancel. 29 plus 2, 31. Let's move on. Let's bring Renee over. I missed my card. Well, I'm running out of breath. Gives me a moment to retrieve. All right, so we're trying to write piecewise functions. We're trying to solve them for an integer value, and we're trying to find out when they're less than that integer value. So what do I see? I see a V shape down, which means my my left side is increasing, decreasing. So piecewise, then we'll do 41 and 42. Got Alfred Hitchcock going up 4x minus 6 plus 11, and it hinges at x equals 6. That's the x value where everything changes. A 7 gets me a 1, a 5 gets me a 1. It hinges right there at 6. So when I'm less than 6 on this side, my finger's going up. On the other side, it's going down. All right, there's the pieces. Reese's Pieces, Yasser says. Okay. Now, if I want to set this equal to -5, I could do it here. I could do it both places. And -4, -5. And I could set these equations and solve them as pieces, and I've done that in the past. But we have been substituting the y value, -5, and we have been doing it a little more streamlined version. But I like the other way conceptually. So I know that this thing hinges at 6. How far over do I have to go? Well, that's -16. -4 goes into that 4 times. I've got to go 4 units from 6. So I already know that my answers are 2 and 10. Okay, how do I know that? Because right now I'm at x minus 6 absolute value. And we said the inverse of that is dropping a plus minus in front of the number. And so I've got 2 answers. One is +4, one is -4. And I'm going to add 6 to both. Well, there's my 10. Add 6 to both. There's my 2. Okay, so therefore, right here and right here at 10, I'm at a height of -5. And at 2, I'm at a height of -5. And this was the coordinate 6, 11. So let's ask the question, how do you get from -5 to 11? You go up 16. How do I go from 2 to 6? 4. Remember the pieces on this side? +4 for a slope. Could do the same thing over here and you'd see -4. Passing through the coordinate x minus 6 plus 11, 6, 11. All right, so now I've got -5 and I want to know when I'm less than -5. Well, these y values aren't less than -5. Right? And I'm looking for x's here. So let's get rid of the -5. This is 2 and this is 10. Well, what direction am I going? My x's are getting bigger than 10 and they're getting less than 2. So from a conceptual standpoint, I'm less than 2 and I'm bigger than 10. And this needs the word or, but interval notation, less than 2 goes to -infinity. Union 10 to infinity is a better way of describing intervals. Intervals on an x-axis, 2, 10. The numbers in between didn't work. Those numbers did. And this is the way we want to express it. All right, let's see. Got to back Rene up. Move Rene in this direction. Not trying to do misdirection, trying to do this direction. Yes, you can tell I've done a lot of math in the last 3 hours and I'm getting a little cuckoo. All right, subtract 4, 2, divide by 4, 1/2. The inverse of E is ln. And I asked you to actually put this in a decimal approximation because I've asked you to memorize that for the past 2 months. And that's approximately -0.7. And then I got to add 3. So I'm getting an approximation of 2.3, I believe. And if I see ln of 1/2, and I see minus what did I, at -3 becomes +3. If I see that answer, I'm happy on one level, but I'm sad on another. I'd like to be happy on both levels. All right, let's erase that because it's hard to see the next problem. And remember, you just play these again. I'm going through it quickly, I know. I got to take a cube root of 27, I got to square it, and I got to reciprocate it. So that's conceptually seeing it. If you're not seeing it conceptually, then you got to do it out algebraically. 27 to the x equals 1/9. You got to get the same base, which is 3 to the 3 to the x, base 3. Over here, 3 to the -2. And therefore, 3x equals -2. And there's our answer, negative 2/3. But if you can just see the answer and write it, well, that's 10 seconds or less. Move on to the next problem, which is 64 to the minus 1/2. Maybe you're seeing that as 1 over the square root of 64. I hope you are. If you are, go to the next problem. 8 and 4, 2 cubed. X equals 2 squared, 2 minus x. Okay, I think I've got to do that one over here. So 3 times x has to equal 2 times that number, which is 4 minus 2x, which I got in trouble with on problem 29 because I couldn't do a negative 1 properly. That's all right. All right, so I'm going to bring 2x this side. 5x equals 4, so our answer is 4/5, which is the 5th root of something that is raised to the 4th power. I can't do that in my head. All right, let's erase this, get it out of the way. 4/5. You can replay it. Inverse. Well, I know I'm going to start with an x, and this is like solving an equation for a number. That's in that form. I'm going to subtract 3. I'm going to divide by 5. I'm going to do the inverse of log base 4 is 4 to the. That should be my inverse. How do I check my inverse? Plug in an easy number. Let's plug 4 in. If I plug 4 in, I get 1 times 5, 3, 8. So let's plug an 8 in and hope. I'm getting near the end of the video. That means I'm ready to make a mistake. 8 minus 3 is 5. Divided by 5 is 1. And 4, 8 in the bottom function. 8, 4 in the top. Checks. Okay, a little harder. Sum of 2 cubes is a product. We've been working on the cube root of 27a9. I hope you're saying 3a to the 3. Hope you're saying that. Cube root of 125, m to the 6. I hope you're saying 5m squared. Remember what m squared times m squared times m squared gets you. All right, everything after this, I don't even look at this anymore. I'm just looking at this and I'm squaring the first number, 9a6. I'm squaring the last number, 25m4, and they're both positive. And now I'm looking at 3 times 5 is positive 15. I remember to change the sign, and I've got a cubed m squared. Right? If this had been x and this had been y, you would have said 15xy doubled 30xy. Right? I'm not doubling here. I got muscle memory with binomial squaring. Woo! Do so many of those things. All right. So here we have x, y, and z. And this problem is no different than finding out a couple of coordinates for 2x plus 4y equals 8. It's no different than that. You put a 0 in, you do the math. I put a 5 in, that's gone. I put a 6 in, that's gone. I am only solving this equation, and I think I can see that a 6 works. 6 minus 1, 5 squared, yep, that works. And I think I can see negative 4 works if I hold those constant. All right, your turn the next time. Make that a 0. I think you want a 1. Make the first one a 0. I think you want a 5. Well, what could the middle one be if these are gone? I hope you say 10. That'll get me 1. Oh, nope, sorry, 8. Getting towards the end of the video, time to make mistakes. 8 gets me a 1, and so does 4. 4 minus 6, right? 4 minus 6, negative 2 squared. 4 divided by 4 is 1. I won't do the last one, but what makes this equal 1? You tell me. 50. I'm doing a logarithm, and I ran out of room, and so I really do want to highlight this process because this is the essence of the course. Adding 4. 2 to the 3. Oh, sorry, got to divide by 3 first. Get towards the end. 1. 2 to the 1. I'll put it like that. Multiply by 5. 10 should work. 10 divided by 5 is 2. What do you put on top of 2 to get a 2? 1 times 3 minus 4 equals negative 1. Move on. All right, I can't move on. I got to move a board here. Hang on. Should I add this in a better position? When it's coming over. Oh, there was no rotator cuff. Ooh. Then. Oh my God. All right, here we go. Renee. Back you up over here, turn you around. Let's perpendicularize you. Negative reciprocal. Yeah, let's get you a little closer. Parallel parking. There we go. All right. A few more problems if I can get myself over here. Okay, yeah, see everything. All right, so we're basically doing the same thing here. We're solving for t. What are you doing from a conceptual standpoint? You're subtracting d. You're dividing by b. I didn't leave enough room. You're doing c to the. That's the inverse. The inverse of log base 5 of 25 is 5 squared equals 25. So log base 5 of 25 is 2. We start with the 25 and we get a 2. Here we start with a 2 and get a 25. The inverse of logging base 5 is 5 to the. So this is the inverse of log base c is c to the. And I think I'm done. That's all I had. Yep, so that's gone. Maybe if you keep hearing this, it'll make sense. So this is the same thing as 2 ln of 3. That's our log rule. How do we do that? Well, we changed 9 to 3 and it's squared. And I'm looking for the exponential activity on top of E. In order for exponential activity top of E be seen, I got to change 3 to E to the 1.1. And I think I'm multiplying 2 times 1.1. 2 times 1.1, your answer should have been 2.2. And we're beginning to talk about the rules of logarithms. Oh my. 54 is the cosine of A. I'm so happy it's the cosine of A. Do I remember what I asked? No idea. Do I have the test in front of me? No. 54 is a mystery. What would I have asked cosine of A? Don't know. All right, that's gone. I think I'm out of numbers here. 52, 53. So what's this one? Well, that's 3 over 2. I can do that. I can move the a to the minus 5 here. I can move a to the minus 2 here. We talked about that in previous videos. And I can see b to the 4 over b to the 3. There's one more b there. And I forgot to change the sign late in the video. And so now I can see my answer is 3a cubed b over 2. All right, now I want the y-intercept. I'll do that one here. You can just see if I plug in 0 for x, I'm erasing that. I'm erasing that. I'm erasing that. I plug 0 in. I get minus 27. What happened over here? I lost that number. I forget what that number was. So whatever that number is, that's my memory. I got minus 27n plus 7. Oh, God. All right. Getting a little silly here. So is there another problem? Yes, there's one more down here. Hopefully you can see it. Running out of room. Square root of 50 is 5 root 2. All right, 25 times 2 is 50. 6 is a multiple of 2, so I can take 3 out. 21, I can take 10 out. And 1 stays in, the radical sign. All right, so got up real early to do the 10 graphs or whatever, the 48 problems, getting some work done in between. And classes start in half an hour, I guess. So I'll sign off. And hopefully people are, Yasser, you said, does it take 45 years? I don't think so, Yasser. I got a feeling you're doing these almost as fast as I am or faster, because it seemed like you got some real good native ability. I don't think I do. So you're going to go past me pretty soon. All right. Ciao.